The subject of this video will be the creation of a two-sides PA weld inspection using a compound scan. The specimen. The first step into creating a setup is defining your specimen. It will help you create your UT configuration and also help you with data positioning. We will create a UT phased array configuration for the following specimen. It is a 40 millimeter thick plate with a 30-degree V weld. Once the specimen is done, click Accept. To display a drawing of your specimen on the sectorial scan, activate the overlay and select how many full skip you want to display. For more information about how to create your specimen, please watch the specimen creation video from this series. To create your UT configuration, go in the Channels menu. By clicking on the Current Channel button, you can rename your channel. In this case, we will name our channel Skew 90. Then, select the configuration you want to create. In this case, we will select Phased Array Pulse Echo, and select which probe and wedge will be used. You are now ready to start creating your focal laws. Click on the calculator. By default, your skew angle is 90 degrees. Multiple sweep types are available. Let's see each of them in more details. The azimuthal sweep uses the full aperture to create each beam. As seen in the animation, the same set of elements create each focal law by applying different delays. This is represented by the red lines above the probe. A linear sweep uses an aperture that moves along the probe to create each beam. As seen in the animation, each set of elements creates one focal law and then moves by the selected resolution and creates another one, and so on, always applying the same delays. A compound sweep uses an aperture that moves along the probe to create each beam. As seen in the animation, each set of elements creates one focal law, then moves by the selected resolution to create another one, and so on, applying different delays to create each angle. In this case, we will select the compound sweep. The beam density parameters appear, allowing you to select between sparse or dense, dense being the improved resolution for each angle. Next, we will learn about beam density, sparse. Each law is an increment on the linear sweep and on the angle sweep. This means that the exit point moves and the refracted angle changes between each law. The angle range, defined by start angle and stop angle, is evenly distributed over all exit points. Therefore, the angular resolution is automatically set by dividing the angular range by the total number of apertures. Motion of the aperture is defined by the aperture, first element, and last element parameters. Next, we have dense. With dense, each law is an increment on the linear sweep or on the angle sweep in alternation. This means that the exit point moves or the refracted angle changes between each law. This creates a sweep that is denser than the sparse compound sweep. It also provides a sweep with density similar or better than the traditional azimuthal or linear sweep. The total number of focal laws is 2 times higher when sparse. Motion of the aperture is defined by the aperture, first element, and last element parameter. For this example, we will select dense. Then, as seen previously, you have to select a start and stop angle for your inspection. And we will use an aperture of 16 elements, a first element of 1, and a last element of 64 to use all the elements available on the probe. This means that each beam angle will be created using 16 elements, and for each angle, the first element will increment by 1 element as seen previously in the animation. The reverse probe could be used if the probe was set up upside down on the wedge so that the first element is at the top of the wedge instead of the bottom. As for the focal point, you have to choose between half path and true depth. Let's take a closer look. There are two focal point types, true depth and half path. True depth is the same depth in the material for each focal law. Half path is the same distance along each focal law. In this case, we will select half path with the depth of 110 millimeters along each focal law. The position of the focal point is displayed on the left by a black dot and a black line. You can also set up your time base directly from the calculator, or set it to none in the calculator and set it up later in the UT settings. Let's go ahead and set up in the calculator. 3 options are available: half path, true depth, and distance. You can visualize your selection by looking at the red area of the display on the left. Half path and true depth uses the same concept as for the focal point. As for distance, it's the distance from the center of the weld. The selection of the time base will affect the display of your sectorial scan and the length of your A scan for each focal law to display only what's in the red area. Once you are satisfied with the display on the left, click Accept. Next, we are going to create a Skew 270 channel. To create the channel for Skew 270, we first need to create a new channel that will be a copy from Skew 90. Every time a new channel is created, it will be a copy of the channel that was selected previously. If we want to inspect both sides of the weld at the same time, we need to create a second channel. To do so, click on the Current Channel button and select New. Name your new channel. In this case, we will name the channel Skew 270. Creating a new channel, always copy the currently selected channel. So all the parameters from channel Skew 90 have been imported in Skew 270. You can verify your parameters by opening the calculator. The only thing we have to modify to this channel are the skew angle and the probe connection. Change the skew angle to 270. You can see your probe moving on the display. Finally, change your probe connection according to your splitter cable. If you're using a ZTech splitter, the first connector uses connections 1 to 64, and the second connector uses connections 65 to 128. You want your probe connection in the calculator to be the connection on which your first element is connected. In this case, it's connection 65. To see your full weld coverage, tap the button at the top right corner of the left display. Once you have made all the necessary modifications, click Accept. Now that you have 2 channels, one for each side of the weld, let's display them both at the same time. For a simple layout, the predefined layouts can be used. To do so, tap on any view and select the last button of the contextual menu. The predefined layout list opens. Select the appropriate layout for your setup. In this case, we will select the 2 volume corrected with the 2A scan because we have a 2-phased array channel. To create a custom layout, please refer to the view layout video of this series. Thank you for watching. If you have any questions, please contact us at support-utproducts@ztech.com.